Okay, guys, we're going to continue on with a Boyle's Law example today. So remember Boyle's Law, the equation is P1 V1 equals P2 V2. Your ones relate to the initial conditions. The twos relate to the final conditions. So basically, we're going to take a gas at a certain pressure and volume, and we're going to change something about it. We're either going to change the pressure or we're going to change the volume, and then we want to know what's going to happen to the other variable. Okay, so our first problem states that a gas occupies 12.3 liters at a pressure of 40 millimeters of mercury. What is the volume when the pressure is increased to 60 millimeters of mercury? Okay, so just like we've talked about in the past, we want to be really organized with our data. That's really important when we talk about gas laws. So I'm going to make my normal lists of my variables. So I'm going to list my P1, my V1, and then my P2 and my V2. It doesn't matter how you do this. Again, if you have a certain way of organizing your information, feel free to use that. This is just my way. So if I look at the pressure, the initial pressure is going to be 40 millimeters of mercury. So I'm going to write that down here, and I'm not going to drop my variables, and I'm going to keep my units with it. Or I'm sorry, I'm not going to drop my decimal places, not my variables. My initial volume, it's telling me that a gas occupies 12.3 liters. So that's going to be considered my initial volume. And I'm going to keep my unit with that as well. And then my question goes on, what is the volume when the pressure is increased to 60 millimeters of mercury? So we're increasing the pressure. Our P2, so that's what we're increasing to, is 60 millimeters of mercury. And my V2 is what I'm interested in, or my X. Doesn't matter to me whether you keep it as V2 or X, completely up to you. Okay, so a couple things. If you notice, I have millimeters of mercury over here, millimeters of mercury over here. That's what I want to see. I want to see consistency between units. If this unit, let's say, was kilopascals, this unit would have to be kilopascals. And if it wasn't, I would have to convert it. Okay, so I need consistent units from one side to another. So keeping that in mind, when I solve for my X, my unit's going to be liters because I'm starting with liters here. Okay, so now I'm going to plug in according to my equation. So remember, my equation is P1 V1 equals P2 V2. My P1 is going to be 40.0 millimeters of mercury. And again, just to be exact, you should keep your units. If you're not, obviously turning your work in, that's not super crucial to do, but I would suggest that you get in a good habit of doing that. Your V1 is going to be 12.3 liters. And then we're going to be substituting in our P2, which is 60.0 millimeters of mercury. And then finally our X. I'm running out of space. Okay, so we're going to solve for X. We're going to divide each side by 60.0 millimeters of mercury. And over here, 60.0 millimeters of mercury. Okay, so our X is actually going to turn out to be 8.20 liters. Okay, my X corresponds to a volume, and I know that my volume is measured in liters. So this is going to be your final answer. As far as sig figs are concerned, notice I have 3 sig figs here. How did I get that? Each of my numbers here has 3 sig figs. So my problem has to end with 3 sig figs. Okay, so that's how you would do a Boyle's Law. Most of them are very similar to this. The most important part is going to be to identify your variables first and then plug and go. This is the easy part down here. The harder part sometimes is identifying variables, making sure that your units are consistent.